Welcome to Eureka. I am Gauhar Raza and you are watching Eureka. Monsoon prediction is like science fiction. Rain prediction is nightmare for the scientists. It's a black box which has never been unraveled. These are the comments which we often see in media, and the comments are not only made by media persons, science communicator and even scientists have made these comments. In order to find out what is the truth, where do we stand, we have asked Dr. Laxman Singh Rathore to explain during next half an hour where do we stand as a nation. Welcome Dr. Rathore to Eureka.
My pleasure.
Let me begin by asking a simple question: how difficult it is to explain scientifically and also predict what is this phenomena called monsoon?
Prediction is anything, be it atmospheric process or monsoon per se, is a very difficult domain. And when you predict anything, you deal with uncertainty, and that is a very large component of weather and climate. And therefore, when you are dealing with uncertainties in the prediction, the focus is to minimize these uncertainties and leave alone prediction. At the time when you predict atmospheric phenomena, you have to define the atmospheric initial state at the given point in time when you are predicting it.
Correct.
And that itself is a challenge.
And the number of factors which are going to influence over a period of time, because at time t0 you know the state, but the number of factors that are going to influence as the phenomena progresses is going to be very, very difficult. How do you do that?
Gauhar Sahab, this T0 is a very cumbersome problem, and as I mentioned, you define the initial state through observations. There is no other way.
Correct.
And therefore, in order to...
And it is a large phenomena as far as space is concerned. So, you have to observe things at a very large level, which means throughout the India and beyond Indian boundaries, you need to observe the phenomena at T0. It's only then you can predict something.
Not only India or region, you have to simulate the global atmosphere.
Right.
And even if you are predicting Indian weather, because weather and it doesn't have any boundary. Today it is over Africa, after 5 days it is over India. So therefore you have to simulate.
And right from El Nino, which is
entire atmosphere, you have to simulate three-dimensionally. And therefore you need to have large number of observations, not only at surface, but you have to do vertical profiling of the atmosphere. And say, for example, if you are running a model of 22 kilometer horizontal grid resolution and say 64 vertical layers of the atmosphere, and imagine the mesh which is created around the Mother Earth. Right. And you have to define the value of each meteorological parameter, temperature, humidity, pressure, wind at each of this point. And you don't have observations. You have very few observations, which again are very random and discrete. And then how to do it? It's the first challenge. And here we are rescued by the satellite observations.
Right.
But again, satellite do not observe temperature. It does not observe wind. It does not observe humidity or pressure.
And in any case, you can't have vertical observations.
Well, we have. We have now satellites have vertical profilers, they have sounders, but it doesn't per se record meteorological elements. It only sends the spectral properties or radiance emitted by the bodies. And you have to translate these radiative properties into these meteorological elements.
Correct.
And again, in this process you have errors. So when you define T0, as you rightly mentioned, you have large amount of error even in defining
the initial
state of atmosphere.
Right. And if you are able to predict the thing, then the errors will get amplified.
That's right.
Over a period of time.
Right. That's what we call.
How do you introduce corrective measures?
Right. The basic question here is, as you rightly mentioned, at T0 that is the initial conditions, and when you run the models you extrapolate both in time and space, and this error magnifies, and we call predictability. If the error is x at T0 and in time when it becomes 2x, it is called theoretical limit of predictability, and beyond this time you can't predict theoretically. And in tropics this is 5 to 7 days, and in extratropics it is 2 weeks or even larger than 2 weeks because of the intrinsic property of atmosphere and the weather systems we are dealing with. Now this extrapolation is where the model come into the picture.
Right.
Here you treat physics, you treat dynamics, and you treat entire atmosphere as a fluid and apply the laws of fluid dynamics and hydrodynamics to
right from second law of thermodynamics.
That's
to
right.
all those complex equations.
That's right. So, and then on top of that you have to have a continuity of motion. That also you calculate because dynamically you deal.
But in India, you have been associated right from the beginning in development of this prediction model. I remember the days 80s when first time this model hit the headlines in the country, that we have been working very hard to develop a good model. How has it progressed? Where do we stand as compared to other countries?
Well, this numerical weather prediction started way back in early 80s in India Meteorological Department, but major thrust came in mid 80s with the setting up of National Center for Medium Range Weather Forecasting, where we imported the first supercomputer, the Cray XMP, and we started.
And it was banner line.
Right, and then we first started with very coarse resolution model, which was at a horizontal grid resolution of 250 kilometers.
Correct.
And then we graduated to 150 kilometer horizontal grid resolutions, then to 80 kilometer, 50 kilometer, 35 kilometer, and today we are operationally running at about 20 kilometer.
I was very fascinated and felt very proud when last time our coast was hit by this storm and about 100 million people were shifted. So many lives were saved. About 10 years back, we lost a lot of lives in the country. About 5 years back, in United States of America, lives were lost. Can we say that today we are comfortable enough to predict the weather, at least the big storms which are going to hit our coastal areas, and also take corrective measure, reach the last man in the street and tell him now it's the time to move? Is it, will it be a correct assessment?
Gauhar Sahab, predicting extreme weather events is a challenge globally. And among these extreme weather events, if you really categorize, cyclone is one which is better monitored and also better understood, so therefore better prediction. But we have really come off a very long way. Till 2009, we were able to predict only 24 hours in advance. And then we started 72-hour forecast, and last year onwards we are now giving 120-hour forecast. That means 5-day advance forecast. Now this has 4 different components. Like at the sea, when there is some conditions, organization in the cloud and other conditions which are congenial for intensifying into the cyclonic storm, our first challenge is whether a cyclone is likely to form. Once formed, then you have to really
monitor its
movement and intensity both. So, in what direction it is moving, likely to move, and whether it is going to further intensify, if so, then by what magnitude. Now, that is as long as it is on the ocean, but the major challenge comes when it comes to the coast. And when it comes to the coast, you have to really predict at its time of landfall, place of landfall, intensity of wind it is likely to have at the time of when it is crossing the coast, the precipitation field, and most killing event, that is how much storm surge and by what area it is going to make the inundate. So, these are all component, not only that it is a place of hitting and its intensity, you have to really give a comprehensive picture of its total
and you impact. Can't create panic. You cannot create panic. So, you have to be 100% sure that something disastrous is approaching our coast. We will continue the discussion. Don't go anywhere. We will come back soon. Welcome back to Eureka. We have Dr. Laxman Rathore with us, and we were discussing that predicting cyclones is everybody's concern, but predicting monsoon probably is our concern. And this year again, we are predicting that monsoon is probably going to be not very comfortable, below normal. Now, how difficult it is to predict monsoon, because a very large population in the country depends on monsoon. Though we have shifted from agrarian society to, or in the process of shifting from agrarian society to an industrialized nation, but still very, very large population depends on that. So, how are we comfortable? Are we comfortable? Can we predict things?
Gauhar Sahab, let me tell that monsoon is a very vast, rather one of the vastest atmospheric phenomena, and therefore it is of interest to all the meteorologists, be it Europeans, be it Americans, everybody, because if they are not able to simulate monsoon, they can't predict weather over Europe or America correctly. And again, predicting monsoon in a seasonal scale, that is long range or long temporal range, is again a big challenge. When you come in short and medium range, then atmospheric physics you can deal in a much better way, and then you are able to identify exactly or with more accuracy where you are likely to get the system formed and what direction it is moving, etc. But predicting in April or May or June when monsoon is likely to come beforehand is a challenge, and this has to come through understanding the teleconnections of the monsoon with other global parameters. And in this temporal range, it is the oceans which better drive and has a long term memory to influence the atmospheric processes. And therefore, be it Pacific, be it Atlantic, be it Indian Ocean, from where it originates, their conditions really determine the health of monsoon.
How well placed we are as far as the scientific model is concerned? Are we better than other countries because this hits us most intensely, or we are lagging behind as compared to other countries which are not directly affected by, they are indirectly affected, as you said, it is the largest phenomena. So, their atmosphere, their temperature, their humidity is going to be affected, and finally their crop pattern, that would change. But the question is, since we are going to get affected badly by any change in monsoon or weather, how well placed our scientists are to predict as compared to others?
Let me tell that we are the only country who are giving operational forecast in that temporal range. Other countries, of course, developed nations are giving experimental or product generation is being made, but operational forecast is done only by India, number one.
So, we can make a statement with responsibility that we are almost at par with anybody, any scientific community anywhere in the world as far as meteorological prediction of monsoon is concerned.
Yes, yes, we can make that statement, and we have come a long way. Our earlier models were most empirical, and then we came down to the statistical models, and then
during our childhood, generally the old person in the village was consulted. How is it going to be? This place in Delhi called Paharganj was traditionally a place where people came every year before monsoon and predicted how it's going to happen. But today we have scientific models to predict.
So it is all science-based prediction system. That is what we deal in meteorology. And when we deal with the science-based prediction system, that means you have to not only predict atmosphere, but also predict ocean and the couple ocean and atmosphere. So now presently we are running coupled ocean atmospheric models to really simulate and predict both in time and space how the monsoon over different segments of its 4 months stay over our spatial domain is going to behave.
Generally, there was a comment made by on behalf of the scientific community, and it was almost official as reported to the media, that other nations are trying to create a panic as far as this year is concerned. So, is it a correct kind of a statement where we are saying no, situation is not so bad, we will be able to cope up as far as monsoon is concerned?
It's a very interesting question. It is for public to assess, but well, yes, many agencies, they really threatened us that El Nino is going to come and monsoon is going to be very bad, and we said no, though it is going to be below normal, but it is not going to be that bad, and El Nino, wait for El Nino, it is not going to be only factor first of all, and even if it comes at a later stage, and now they have changed their stand. Earlier they were telling that it is going to be very intense warming over the Pacific. Now that is not the case. Now they have changed their forecast, and that somehow give a reflection, because after all, if there is a bad monsoon over India, it really changed the entire global agro-commodity trading processes.
Absolutely.
And therefore, those countries who are searching for global market, they get advantage over India. And so, because India is a big consumer as well as big producer, and if you threaten India that India is going to be very bad, so India will not export and also will not compete, and therefore the global market commodities prices goes up, and then those who want to sell their commodities,
they gain.
They gain.
They gain by creating a panic in third world countries,
right,
because we have very good relationship with third world countries, and therefore the market will be influenced intensely. We will continue the debate. I have to take a break. Don't go anywhere. We will come back soon. Welcome back to Eureka. Dr. Rathore, we were carrying out a very interesting debate that how predictions become political and globally political. In order to predict, in order to pass on the information, in order to translate this information, scientific prediction, into policies, in order to reach the last person of the country, you require a huge network. It cannot be done in a jiffy. You sitting in your office here and saying that I predict monsoon is going to be bad, good, ugly, whatever, it doesn't reach the last man. It doesn't reach the political quarters. It doesn't influence the finance minister. For that, you have to have a very, very large network. How do you do it?
Basically, you rightly mentioned that weather influence every sector, and there are 30 broad segments for whom we have to provide organized or semi-organized or not organized, but kind of service. There are certain sectors which are very well organized, like aviation, agriculture, hydrology, power. These are the sectors which are very well organized, and there are less organized sectors where user will fetch this information because his financial stakes are too large, and he can gain or can lose if he is not doing weather-wise.
Completely wiped out.
Or completely wiped out. So, that is the second segment. And third segment, public at large, who are not really well aware, and but they are very badly influenced, particularly by extreme weather events. And therefore, the approach for information dissemination for these three segments are entirely different. For example, aviation, you have to have every half-hourly system to be, and then you have to tell the pilot, and you have to tell the aviators as to how to operate and what are the things which to be kept in mind, and they're extremely good system. So also for agriculture.
Weather prediction always has had a very close relationship with aviation.
Always.
Right from the beginning.
Always. Yeah. And so also agriculture. Right. Because nothing is happening without, right from the selection of the cultivar to time of sowing, time of irrigation, and pesticide application, so on and so forth. And this we are doing in close association with Ministry of Agriculture and Indian Council of Agricultural Research and state agricultural universities.
And they also have very large networks to approach the
We have jointly set up this network, Ministry of Earth Sciences and Ministry of Agriculture, and we have set up 130 agrometeorological field units at state agricultural universities. To them we provide the district specific forecast for next 5 days, and also now we have started giving 20-day forecast. They translate this forecast into crop specific advisories, identifying as to what are the stress level in the crops grown in their area. And then the last mile problem, to disseminate information to the farmers. It's very complex, and that we done through multi-pronged strategy.
And at each level you require expertise, scientific expertise, and this large network that has been created is probably as efficient as anywhere in the world.
This network no other country has. Let me tell you that Agromet service which is being rendered in India is no country, including United States, they do not have that kind of service, where we are reaching out to the farmer even through mobiles. As on date, we have 54 lakh farmers who are accessing information on their mobile.
Their mobile on maybe second basis or
That's right.
minute
That's right.
basis they are doing it. You come from a village and very agrarian atmosphere. Your schooling was done in a village, and therefore weather and agriculture has been close to your heart.
Yes, and therefore I studied agriculture, and from agricultural scientist I turned as an agrometeorologist.
And you have done excellent, and you have been rewarded by the country, recognized by the scientific community. Would you like to give a message to the younger generation?
The message is that if you really have conviction, if you really want to learn things, you have to be inquisitive. And the peer learning is very critical. Through peer learning, you can fetch knowledge which you really can't get by any other mode. So, and work sincerely, and particularly those who come from the rural background, I would say that
they can excel and India can excel.
That's right.
This is what you have been saying. Thank you very much for watching Eureka. Dr. Rathore would be happy to answer your questions. You can write your questions, comment and queries on eurekarstv@gmail.com. Thank you, Dr. Rathore. It was a pleasure to have you.
Thank you, sir.